introduced to distance time graphs in the part 1 video. We're going to look at a couple more examples of distance time graphs and try and figure out some information from looking at them. The first graph we're looking at is right here, and the description is written on the left side. It says, Robert left school at 3:30 p.m. He walked home. On the way home, he stopped to talk to a friend. His sister Sarah left the same school at 3:45 p.m. She cycled home using the same route as Robert. Here are the distance time graphs for Robert's and Sarah's complete journeys. So looking at this description in the graph, we should be able to first figure out which line shows Robert's trip and which line shows Sarah's trip. So we figured out that Robert's trip is shown in red and Sarah's trip is shown in blue. We're going to look at each part now of Robert's trip first. So the first part is highlighted in bold there. And we first want to find the exact distance that he traveled in that first part and the time it took him. So you'll see that the amount that that line goes up is the distance. And then the amount that the line went over in that first part is the time that it took. So if we subtract the two y values, we'll get the distance, which is 1.5 kilometers. And subtracting the x values gives the time that that first part took, and that's 15 minutes. Now using these two numbers, the distance is 1.5 kilometers and the time is 15 minutes, we just divide them to find the speed that Robert was going for this first part of his trip. So you're going to do distance divided by time. And you see if you do that math, 1.5 divided by 15 is 0.1 kilometers per minute is how fast Robert was traveling for the first part of his trip. After that, it says that Robert stopped and talked to a friend. And then the last part of Robert's journey, he was again walking home. So calculate the speed on this walk home by figuring out the distance and dividing it by the time that this last part took him. If you did this correctly, you would have done the distance is 3 minus 1.5, that's the y values, to get 1.5 kilometers. And the time was the two x values. It was from 4:05 minus the 3:50 at the beginning of that part. And so his time was 15 minutes. That's 1.5 kilometers divided by 15 minutes. Again, his speed in the last part was 0.1 kilometers per minute. Now let's look at Sarah's journey. That's the part in blue where she was cycling home. Look at her y values to find the distance, the x values to find the time, and then divide them to find her speed. If you did this correctly, you'll see that Sarah traveled 3 kilometers in 15 minutes. So that comes out to be 0.2 kilometers per minute. All right, another important part of this graph is looking where the two graphs intersect, where that red line crosses over the blue line. And you can see that it's circled on the graph. This point shows where Robert and Sarah were at the same point at the same time. The ends of the lines show when Robert and Sarah get to their destination. All right, the second and last graph we're going to be looking at in this video is a race. This race is between Eric and Ben, and this again is a distance time graph. So you can see by looking at this graph that the distance goes all the way up to 40 yards, so we know that this race is 40 yards long. And we're going to start by focusing on Eric's race. That's the bold part in red. And just by looking at the shape of his line, we should be able to tell how he was running this race. When he ran quickly, when he ran slowly, when he stopped, things like that. Then if we focus on Ben's race, the bold blue line, we should be able to see how Ben ran the race. We're going to go back to Eric's race and look more specifically at the numbers. So you can see in this bold red line the first part of his race. And like we learned on the last graph, we want to find his speed here. So start by finding the distance that he ran in the first part and the time he ran in the first part. And then using that distance and time that you just found, calculate Eric's speed for the first part of his race. Next, Eric seemed to take a long break and stayed in one place. We should be able to find the speed that Eric finished this race in. Next, we're looking at Ben's race. And since it seems like he ran a steady pace for the whole race, use his beginning coordinates and his very end coordinates, the 4:35, to find his speed for this race. Last, we just want to look at what happened in the race overall.